All right, so I'm here to give you a little bit of an intro into Kubernetes. I know Dan and Peter talked a little bit about it yesterday, but I wanted to give more of a intro or like a Kubernetes 101 because he burned through it very quickly. I wanted to talk about like how you could use it in your company or how you could use it on your personal projects because it is a very powerful tool. Like anything, it is just a tool. It has its shortcomings, but it has, in my opinion, enough benefits to overcome any like weirdness. All right, so first I'm gonna just talk about who I am, and then I'm gonna dig into what is Kubernetes, and then I'm gonna walk you through some of the primitives, some of the like building blocks that you would use in Kubernetes. Then I show you what an example app will look like. Then I'm going to actually walk you through a real-world example. I'm going to walk you through our production environment as it stands right now. Hopefully nothing goes wrong. I mean, it's production, so it should be all right, right? And then if there's any time, I'll open it up to questions, because it's a very big topic. And also, if I'm moving too fast, speaking too fast, if there are questions, any confusion, please feel free to throw questions out, because it is a very in-depth topic. I've been using Kubernetes for about 2 years now. I forget what is a basic thing and what is like a more complex thing, just because I use it all the time. I'm Tom Sterrick. I'm at KCHDPQ on Twitter. That is my amateur radio handle. I'm sort of an SRE right now. I make things big and then I make sure they stay there. Companies need to scale and need to do things, and I make sure that's possible. I have my own company, We're Productions. It gives me a little bit of leeway to try things out under a bit of a company umbrella, so if something actually turns into a product, I can package up as a product, and hey, there's a company attached. So digging straight in, what is Kubernetes? So first, there are going to be a lot of nautical analogies because it started with Docker and the whale, and it just kept going. So Kubernetes, it's basically a container ship. You package up all of your stuff into little Docker containers, and from the outside, they just it's like I forget when it occurred, but the shipping revolution, when they started using standardized containers on like real ships, like you see there, suddenly you went from hours and days and weeks, like literal weeks, to unpack a ship and then repack a ship. And now you're talking, you can turn a full container ship around in, 8 hours? In and out, you completely unload, reload, because you don't have to care about what's in the container. The same thing is true with Kubernetes. You use a Docker container. I believe there are other forms of containers supported as well, but the community is built up around Docker. And Kubernetes doesn't have to care. Like, it has insight into what's going on, but at the end of the day, it's just a bunch of containers, and it orchestrates them together. It makes them work. It links them together. It provides load balancing. I'll show you as we move through how much it does for you. In fact, it made a lot of stuff very easy. And if you ever see K8S, right there, that's sort of the accepted abbreviation for Kubernetes, because Kubernetes is long and annoying to type sometimes if you're in Slack. So this is sort of what it looks like from an architecture perspective. I will dig into each of these as we go along. But you see the master node here deals. So you would deploy Kubernetes across a fleet of machines. You would typically, anything as small as 3 machines or as large as hundreds or thousands. We always have a master node to coordinate everything. Everything's controllable via the API server, which you can throw REST calls against. You can throw API calls via either libraries or via kubectl, which is the command line interface way of dealing with it. You've got all your primitives, which I'll talk about in a bit. You've got your scheduler, and then you've got your worker nodes and the internet. So the scheduler is where the key comes in, because as you'll see, if you want 7 of something, you just tell Kubernetes, I want 7 of that thing, and it does it for you. It figures out which machines have room for it, puts them out there, and lines it all up, and hooks it all up behind load balancers. I'll dig into this actually on the next slide. Right now. So this is kind of what a small scale app would look like. Again, I'll dig into each piece, but for the sake of argument, we have a hello service that just says hello, and also because whoever wrote it wanted to track analytics on who was coming in, it writes some session information to your MySQL instance. And we happen to have 2 setups of hello just because we want to be very rapid and very responsive. And for some reason, people like hearing hello, so they're hitting it all the time. And down here, we've got just a little Rails instance that just handles like your internal administration of the system. So, yes, just check on it. So the basic building block is the pod. The pod is what you treat is the small number of containers that need to go together. So in this case, because it is a legacy app that we ported in for hello, it expects a local instance of MySQL. So you pack a MySQL container in alongside hello into the pod, and then the pod acts as a machine, like a unified machine. The MySQL instance and the hello instance talk to each other over localhost and over ports on localhost. Yeah, it's the basic building block of Kubernetes. Now, deployments are an abstraction above pods so that you can have readiness and liveness probes. You can have all sorts of scaling, rolling updates, and rollbacks. I'll show you what that would look like in the command line in a bit. But so you basically just tell Kubernetes, this is my deployment. This is in YAML. And depending on your opinions of YAML, you might just want to strip this out. But you tell Kubernetes, this is a deployment, its name is hello, I want 7 of this thing, and then you add some labels. Labels are how the various pieces of Kubernetes know how to search for each other, find each other. And then you spec out what the container actually does. So each container is named hello. You pull your Docker image, in this case, hello version 1.0.0. You tell it what ports this container needs to expose. So in this case, port 80. You give it resource limits. So this is only allowed point to vCPU. vCPU is sort of the abstraction for one idealistic CPU. You give it some memory limits. And then you set up liveness and readiness probes. So readiness probes are what tell Kubernetes whether or not the container is actually ready to roll. Like, is the service actually paying attention to internal stuff? So you can expose, as you might be able to see, I don't know how far back people see, you expose a path on it that is a readiness check, and then your service actually tells Kubernetes whether or not it's ready. Similarly, you do a liveness probe. Now the difference is, unless I have these backwards, readiness is I am ready right now. I might not be ready in the future, so please check occasionally, but I'll be right back if I tell you I'm not ready. Liveness is I'm dead, kill the container, start up a new one. So Kubernetes is actually really, so like you see we have 7 up here. I want 7 live pods that are ready to say hello and log stuff to MySQL. And if one of them, or however many of them, actually say they're dead, or they crash out and die, Kubernetes just wipes them off the slate and spins up new ones. Which, actually makes my life a lot easier. And scaling, and you can actually change this live elsewhere. So I'll show you on the UI, but you can actually, there's a web UI, and you can actually go up and change this live on the UI. Just you go to the deployments, and there's like scale button right at the top right. You click that, you tell it instead of 7, I want 100. You click go, it does it straight from the UI. You don't even have to dig into a machine with command line instance. Say you're out and you only have your phone. You can do it straight from your phone. Deployments also give you rolling updates and rollbacks. So what you can do is if, say, version 1.0.1 rolls out, you push the images up to Docker Hub or whatever registry you're using, and then you just change it right here. You hello colon 1.0.1, and then you do the command line. The command line argument is could control replace -f and then the YAML file. And Kubernetes sees, takes in your updates, or takes in your changes, and applies that against the real world. And if there's an image change, it'll actually start rolling updates. So it'll kill one instance of your 7 and bring it back up with the new image. And then it'll do it again, the next one, and the next one. So you always have a working service, which is really handy because you don't have to deal with downtime in a properly configured setup. The new services come up, the old services go down, and hopefully your users never notice. If they do notice, there's a rollback. It's kube control, rollback, deployment, and then hello. And then Kubernetes, which has been tracking your changes, says, oh, okay, the latest change was not a good one. I'm going to go ahead and roll us back to 1.0.0. And it does the reverse of what it did on the rolling update. It kills one instance with 1.0.1 and gives it 1.0.0, and then does it again, so your service comes back to live. Now, I'm saying service. So you have your deployment, but you also have service, which is a separate primitive. It is basically just a DNS name. So whenever you give something a service, in the service, you actually give it selectors. So remember the labels from last time? The selector goes through the existing labels and says, oh, okay, anything with this label attaches to my service. So you could have selector at hello and version 1.0.0 here, and it would do an and comparison, and you would have a 1.0.0 service of your hello. And you specify your ports, so port 80 in this case, and then it just exposes that as within the, I'll get to namespaces in a second, but within the default namespace or whatever namespace you're in, it just exposes it as http:// hello. and any service can reference it by that DNS name. If you need to be a little more explicit, it's hello.default.svc.cluster.local. But usually it's just hello. And the services act as a load balancer. So amongst everything that you've selected in with your selectors, it load balances out across them, and it relies on the deployment's readiness and liveness probes to tell what is valid to be load balanced across. So if half of your stuff, for whatever reason, just isn't ready to go, it'll only load balance across the other half that is. So namespaces. Namespaces are a way of isolating. It's basically like namespaces in any programming language you come across. It's a scope for names. So in this case, I have a production environment of hello and the Rails instance, and a test instance of hello and the Rails service. And they each have their own, so the internet's out here, they each have their own ingress and their own isolated sandbox. They can't talk to each other, but they exist on the same hardware. So you have to remember, within Kubernetes, this is all existing on the same 5, 10, 100,000 physical machines. But they can't talk to each other unless they go out to the internet first. So, yes. And they're really easy to specify in the YAML. It's literally 6 lines. So volume, you probably didn't think, okay, so you've been thinking, I have all these containers, they're alive, they're dead, they go away, they're cattle, like they're here and they're gone, and I can't rely on the persistence of their file system, which you can't. How do I have a stateful service? How do I have something that has files in it? You have a volume. You can, there are a lot of different types of volumes. Some of them are stateful, where they actually rely on a persistent disk somewhere. Some of them are, like down at the bottom, it's called an emptier. It is guaranteed to flush on instance reboot. You have config maps, which, again, I'll talk about them in a second. But config maps can be exposed as a directory where it can reference data that way, and that's a volume. So in this example right here, I've got a Prometheus monitoring setup, which references a config file that actually comes out of a volume, and then references storage, which comes out of a volume, which are they're mounted here by name, and the volume mounts in the volumes down here. Yeah, so volumes are how you store stuff. You don't have to use volumes if you want stuff to like dump and come back on container reboot. Like technically speaking, the emptier down there isn't necessary. But if you want to persist that data, like your MySQL instances, if you want to persist that to disk, you definitely need a volume that mounts to something like a GCP persistent disk, or an Azure persistent disk, or an AWS persistent disk. If you're using a cloud provider, there are other local ones as well. Secrets. Probably wondering, okay, how do I put my SSL certificates, or how do I put my my API keys, or how do I connect to other things, or how do I have secrets and like private information, sensitive information in Kubernetes? You put up a secret. They're isolated to a particular namespace. So if you have a particular secret that you just want locked down to only one thing, and that one thing you're locking down to can act independently, you can give it its own namespace. Namespaces are pretty much free, other than a little bit of configuration. So in this case, I'm putting my SSL certificates in the secret, just as, because I think we used a base 64 encoding just to condense it down. And then this, as well, can be exposed as a volume. So suddenly your containers can look at this and they'll see like /c wherever you mount it. So assume I mounted it /secret, they'll see /secret /tls.cert and tls.key as files, and they can access them and reference them. So config maps. Config maps are just a generic way of putting stuff. We use them a lot for environment variables because we have a lot of them. But anything that needs to, like any configuration information that needs to be dumped into a container that isn't already there. So in this case, how many of you are familiar with Let's Encrypt, the free SSL certificate setup? Okay, so like 3 or 4 hands. Let's Encrypt is a free SSL certificate service. They're only alive for about 90 days at a time, but you can programmatically refresh them. You don't have to care about it. And this, Kube Lego, is an implementation that will attach to any of my tagged services and give it an SSL certificate. It'll manage the auto refresh, it'll manage all of that. But it's a prepackaged thing. So I have to be able to give it some configuration information, and we do that via config maps. So I tell it, like lego.email is my contact email address, and then lego.url is the actual the ACME server that it's hitting to refresh its certificate. Which even that you really shouldn't have to care about. Be curious why it made it in there. I'm curious why they require it as a parameter. So I promised a look at a live demo what this would actually look like, because right now you're probably thinking, okay, we've got a bunch of this little stuff and like you showed me some diagrams, but what does it actually look like? Let's see. So the URL, the web UI this is how you look from the like admin perspective, how you look at your cluster. So in this case, this is the default page that loads up. For the curious and the well-cited, you'll see it's localhost port 8001. That's not because I'm running the cluster locally. This is, like I said, this is a production cluster. This is running up in GCP right now, Google Cloud Platform. But the way you access it is, I don't have it. It's kubectl proxy. It sets up a little proxy on your machine, so localhost port 8001, and then connects using keys and auth tokens to the actual service, so that the web UI is never actually exposed on the web, because you actually would not want to do that. There are a lot of things, like if I wanted to kill this player instance, I could right now. Just delete and delete. So using the proxy actually allows you to, not give the world access to your cluster, because that could be really bad. Because you can actually also create anything via the UI. You just dump it in YAML and it does it. So, if anyone could access this, all of a sudden your cluster would be mining crypto. It just would. Happened to Tesla. Their console was exposed to the internet because they turned off default, and all of a sudden their cluster was mining Bitcoin or something. In this cluster, we've got a couple of different namespaces. We have one for prod, we have one for test, which we just claimed the default namespace. We've got one for demo and one for monitoring. So like demo.company.co, www.company.co, and test.company.co. And as well, you'll see there's, if I make it a little bigger, there's kube public and kube system. those are Kubernetes-specific namespaces. So if you're curious where all your log aggregators and your proxy services and your service or your scheduler services and instances are, they live in those. Best not to dig around in there, because you can start killing stuff and it'll bring it back, but it'll adversely affect your cluster, just because you're messing with the innards of Kubernetes at that point. So you got your nodes. I didn't talk about that in the primitives list, but your nodes are your physical instances. So in this case, this is a small cluster, so it's got 5 nodes, 5 physical machines somewhere, and you can dig into each one and you can see like what its current CPU usage is, what its memory usage is. It has some nice allocation charts. Because there's a difference between requests and limits. You'll see like limits are limits where like this much is allocated out to containers and they can't run over, and the containers that have limits can't run over that. The request is just what the containers on that machine have requested as far as reservations. In this particular setup, there aren't a lot of resource limits, and that's why that's why the request exceeds the limit, because most of the services don't care about limits. And you can go through, you'll see the status of your nodes. So generally speaking, all of these except for ready are false. Like the condition out of disk is false because kubelet has sufficient disk. And then you can see what pods are running on that node. You'll also see like your persistent volumes, which we don't have any. You can also set up roles, so like various people, like you can give a user account, like a web UI user account to each person and attach permissions to that. And it'll reflect what their permissions are in the cluster itself. Like maybe you want someone that can only go through and view stuff. They can't change anything, they can just view stuff. You can give them you can set up the RBAC permission to just give them view, and they can go through and they can't change a thing. All right. So another thing. So you're probably thinking, okay, this is a cluster. How do I do like time jobs? Kubernetes has a cron job set up. So you can just tell it, I want this thing to run once a day. Maybe it's your log cleanup, maybe it's your whatever. And you can just say, run once a day, and it'll do it, as opposed to having to have a container that runs and manages it, and then sometimes that container dies right around the time when it was supposed to kick off its job, and you can get very kind of weird results if you're trying to do things that need to happen exactly once every 24 hours in a container that might not be there or might have bounced. So here, so on this cluster, we don't use deployments. We use the old version of deployments, which are replication controllers. We need to pull that forward. There's just inertia. So this is where your deployments would show up, but in this case, you can see we've got replication controllers. And replication controllers, similar to deployments, you can go in and change whatever you want. So let's go to Marco. Marco is a Node.js instance. It serves HTML resources and mostly static stuff, but some generated templates. So I can go in here and say, okay, I don't want one of this. I want 2 of this. Click go, and all of a sudden I have a second container spinning up, and it'll be there in a minute. So if your cluster, for whatever reason, is getting hammered in one service getting hammered, you can just go in here and up it or down it. You can actually haven't messed with it, so I don't know how reliable it is, but you can set up auto-scaling to like these, set up some sort of metric where these instances their latency is going above a certain threshold. You can spin it more, and it'll just spin out more pods and add them to the load balancer, and suddenly your latency is coming down because you have more resources to deal with those requests. And also in this UI, you can actually click straight through to your logs. And this service doesn't log anything, but you can see it's what you did log out. You can see right here. In the incarnation we're using it in Google Kubernetes platform, or Google Kubernetes engine. There we go. It has a built-in FluentD exporter, so it takes all of these logs and dumps it out to an actual log viewer. So it actually dumps it out here, and because this is a little cumbersome, sometimes we actually also export all the logs from here, from the central point of collection of the logs, into our own Elm instance. And similarly, if you have too much of something and you want to cut down on your spend, on your resource spend, you can just say, I just want one now, and it'll do it. And eventually, one of these pods, it does take a second, but one of their statuses will change to exiting or terminating. And it'll just be going out of the way. Also, we have particularly bad service that has a pretty bad memory leak in it. So every so often, there hasn't been time to fix it. Is the problem. So if you ever have an instance that's just eating memory, you can come in here and you delete the pod that is using too many resources, and it'll kill that pod, bring up a new one to replace it, and users won't notice. I just killed the pod in production because I could. Well, there were two of them, and it actually does a little bit of lead time. It tries to bring up the new pod before it kills off the old pod, so there's a bit of a warm handoff. Let's see. Ingresses. I didn't talk about those. So all of the stuff, services, application controllers, deployments, pods, that's all limited within the scope of Kubernetes. You cannot access that from the outside by default. The way you access it from the outside is you set up an ingress controller. An ingress controller usually is based on the implementation, but usually in your cloud providers, it will go out and register a public IP address for you, and you specify what host names and what paths you want associated with that. So you'll notice, I actually have this branching out from the ingress controller out to different services, and that's because the ingress controller can, based on paths, route it to different services. It makes things nice and easy, and also based on those paths. Because it is such a limited resource, you have an ingress controller with a public IP address, and a very explicit list of permissions. Everything else is limited out, or is locked away from public access. So only what you say is accessible. Right now, they have TCP and UDP. It's a little hairy adding, or they haven't been up on adding other protocols like QUIC into the ingress controller. So actually, I think they just added that one subversion ago. So if you have a custom protocol, hiding it or exposing it by an ingress controller is not the way to go. There are other ways to expose things. From your service, you can give it a type of node. By default, its type is load balancer. you can change it to node port, and then it will attach itself to whatever port you told it to on the node it's on, but then you have to attach via or come in via the node IP address, which, nodes come and go. One interesting thing to note about a node is if a node dies, like say you've got 10 machines and one of them dies, Kubernetes just automatically shuffles the jobs that were on that now dead machine to other live machines that have room. One thing to note, if you're running close to capacity, you don't get that because it will say, insufficient CPU or something on some of them because there's just not room to bin pack them in. Let's see. And I guess I'm actually through my material a little early. So we've got about 15 minutes for questions if anyone has questions. Yeah.
So in your pod back there, you did MySQL, two different pods. So how does it work from a transactional standpoint? So I want to update a record, and I've got two different instances of the database running. I'm assuming same volume behind the scenes, maybe not. Speak to that a little bit if you can.
So, mostly it's a hole in my demo. You probably wouldn't want to do that because two separate instances pointing back towards the same file service. Like if you're running MySQL, it's probably going to work on you. That said, if you're using something like Google Cloud SQL, you use a MySQL, what's called a MySQL proxy, and you put it in place so all of your transactions go to localhost port 3306 or whatever it is, and then that forwards it out to the real instance via proper keys and access control. You wouldn't want to do two MySQL services next to each other. That was 2 a.m. me trying to come up with a good example. Any other questions? I got really deep into the weeds, so yeah.
Your first slide, or one of the first slides you put up, you had a master node, and I saw under the master node, I saw replication.
Yeah.
At the master node level, can you have essentially a failover for the master node?
There is, in the current iteration of Kubernetes, they've been talking about changing it, but it never gets priority. There is always one master node. If your master node dies, the cluster elects a new master node, but in the 15 seconds or whatever it takes to spin up a new master node, your cluster can't scale.
But it brings up a new one.
Yeah, but it does bring up a new one. It does, and if it can't access like more physical machines, it picks one of its existing worker nodes and promotes it to master. Any other questions? Yeah.
You labeled one of your namespaces monitoring. What's that for?
It was just an isolated namespace for our Kibana instances and Logstash instances, and as well as Prometheus stuff. It just made it easier to collect things in one thing, as opposed to having to remember that like our Prometheus instance was hiding somewhere in the test namespace.
I'll ask one final question for
you.
So you mentioned Kubernetes Engine, which is a Google product. How portable are you to different cloud providers, or how locked are you to the Google ecosystem, and how do you balance that trade-off?
So Kubernetes operates completely independently of any of the cloud platforms, and it is a requirement of implementing Kubernetes, or to be Kubernetes certified, they have to just implement the standard. So Google Cloud implements the standard under Google Kubernetes. Yeah. AWS, I don't know if they currently have it, but are working on a similar Kubernetes implementation so that you can have a Kubernetes cluster in AWS. Azure is working on similar if they don't already have it. So there's no vendor lock-in. with Kubernetes. You can also deploy Kubernetes to your local, into like your local machines, like physical hardware you have somewhere in a data center, and you don't have to make any code changes. It just works. So there's no vendor lock-in from that perspective. You are locked in to Kubernetes, but Kubernetes is an open source product that you're not actually paying for. So, any other questions? Otherwise, I'll turn you loose. Thank you for listening to my ramblings at before coffee's kicked in o'clock. Thanks.